Hello, my name is Ely, and today we will be presenting our post-COVID transportation mode choice survey for the course Travel Behavior and Forecast. It is instructed by Dr. Bills, and the group consisted of myself, Amy, and Rizwana. The contents that will be presented today will include the introduction, the method, including the pre-work and survey, our data and our modeling, our results, and lastly, the conclusion. We will start our introduction by talking about transport planning. In transport planning, transport modeling is an effective tool in order to observe the travel behavior and forecast the future demand of travel. Choice of travel mode is one of the most important models which plays the key role in policymaking. This forecasting needs to incorporate the design of transportation systems and develop a system that can accommodate travel demand for different future scenarios. Before starting the implementation of model, one would need to know the information under what conditions an individual will switch from one alternative to a different alternative. The main purpose of this research was to develop mode choice models which can reflect the mode choice behavior of faculty, staff, and students of Wayne State University under different travel scenarios after the COVID-19 pandemic. Next, we have our hypotheses. Starting with disaggregate traveler mode choice models. These models can be developed for various trip lengths and time under different scenarios after COVID-19 in a multimodal environment to forecast the travel behavior using the data obtained through revealed preference surveys. Moving on, we have the Qualtrics survey method, which was adopted in our study. It's a cloud-based platform for creating and distributing web-based surveys. It provides a valid way of understanding Wayne State University faculty, staff, and students' current and future travel behaviors. Lastly, we have the modeling process. Used in this study, it enabled policymakers to test various real and hypothetical travel scenarios. Following our hypotheses, we have our research questions. Our first question would be, how do the values of estimated model parameters vary with the change in the following trip characteristics under different scenarios? An example of this would include the COVID-19 pandemic scenario for Wayne State University affiliated persons. Our second question would include, how can an RP survey improve the efficiency of the survey design and result in better response rate from the sample pool? Lastly, we have our research scope and objective. First objective was to develop a disaggregate traveler mode choice model in a multimodal environment. These environments could include a car, motorcycle, Uline, bus, a scooter, both electric and manual, a bike, both electric and manual, and lastly, walking. Our second point was to get a representative survey sample for the study objects. These study objects would include the Wayne State University community. Thirdly, we have our sensitivity of various modal parameters to determine influence on travel behaviors. These behaviors could include trip length, distance, access and waiting times, cost, environmental and personal safety, and ease of operation. They could also include class location, remote versus on-campus, occupancy limits, which would include how many passengers will the user be willing to be around, and will masks change the occupancy limits? Our next section will include pre-work and survey. Starting with the survey design, we have RP and SP surveys. First, we have revealed preference surveys, which included 2 travel scenarios for Wayne State University community members' mode choice before and during the COVID pandemic. These scenarios include traveling from work to Wayne State University and from home to Wayne State University. An example of this would be whether users tried new modes during the pandemic. Secondly, we have a stated preference survey, SP, which included the behavior change post-pandemic. An example of this would be maximum occupancy acceptance and mode change. Moving on, we had our stakeholders. We had a possibility of 5 stakeholders in our survey. They would include Wayne Rides, the Department of Urban Studies and Planning, MOGO, BIRD, and SPIN. Wayne Rides offered us incentives and a mailing list. DUSP offered us only a mailing list. Mogo did not give us a response. Bird gave us an emailed response, however, we had no incentives from them. And Spin gave us no response. To make our survey more appealing for participants to actually take our survey, we included incentives given to us by stakeholders. Our team created a flyer to send out and post through various distribution methods to reach all Wayne State University community members. The rewards available are 1. The DART 31 Day Pass, which included Q-Line, DDOT, and SMART for all Wayne State student participants. Secondly, we had an annual Mogo Bike Pass with one lucky participant winning by a lottery. Third, we had a $10 off for an annual Mogo Pass, which was available to all Wayne State students and employee participants. These were rewarded to us and sponsored by Wayne Rides. Now we have our timeline. This timeline was of major meetings and events that our team dealt with. It was set in a Gantt chart to show our week-by-week progress as we moved through. We had 4 main sections, which included the topic, meetings, survey, and results. Each main section then had subtopics that were broken down into time sections. Lastly, we had our survey distribution. The distribution methods included were LinkedIn, Facebook WSU-DUSP groups, Academica posts, Wayne Rides email lists, Department of Urban Studies and Planning email lists, class email lists, and other anticipated organization groups, including the Chinese Student Housing Group. Before our survey distribution, we had to run 2 main tests, which included the alpha and beta test. The alpha test ran questions through a logic test, which made sure the questions asked made sense and grammatically checked survey questions. The beta test was externally distributed to a small pool of individuals to ensure the survey was ready for real-time users. These included last edits before the final distribution.
Now I'm introducing the data. So we end up collected 193 total recipients from the undergraduate student, graduate student, faculty, staff, and researchers of Wayne State. We have 193 total recipients, where 31 of them were actually partially completed. If you look at the table 1, which shows them finished responses, and the progress percentage is very clearly showing that some are very low, some are relatively good, and which indicated some need to be dropped and some still can be used. And 7 of the total completed ones were non-WSU members, which we cannot have any results, so we discard them. And noticeably, most of the unfinished responses were happened after collected 100 about surveys. And we have total of 155 surveys were actually finished 100%. And at the end, 174 samples were used in total. For trips with more than one transportation, each transportation we separately recorded. 38 out of 180 partially completed surveys that had satisfactory data, we were able to use it, but low completion surveys were dropped out. Now let's take a look at the socioeconomic ratio of survey participants. We have 34% of students are undergraduates, 28% of students are graduates, 77% of faculty, 15% of employee, 7% of former employee or WSU alumni, 4% researchers, and 3% non-Wayne State community members. For gender, we have over 72% from age 18 to 34, and 18% from age 35 to 54, 8% from age 55 to above. For gender distribution that we have, apparently have more female participants. We have 2/3 of female participants and at the same time have only 1/3 of male participants, and 1% prefer not to say. And the heat map of the trip destination and parking locations tell us some stories too. That from the heat map destination, we can see that most of the Wayne State community members will stay at a center, and then the second one is Old Man. The third on the rest of the heated places are Wayne State Library, Undergraduate Library, Monogin Building, Medical School, different buildings, and engineering buildings. The parking locations, we can see that major parkings are still within the Wayne State parking structure, but there are many parking along the street. However, we can see there is one parking lot from Wayne State is not well used, which is the one that in front of DIA on the Warren. Sampling, we got the data from the Wayne State dashboard. As you can see that they clearly separated the different school identity from student, faculty, and staff members. That they had included the racial, ethnicity, gender. And the data was collected from winter and also from the fall. The final sampling information we gathered including gender, ethnicity, and school identity. Lessons we learned from the data cleaning are the beta test. We should test more responses at this phase, as we happen to see many wrong inputs that we need to correct it, all because of this phase didn't involve more participants to run all different alternatives. The multiple choice questions were set as multiple answer accidentally, but we didn't find out when we check. We didn't check the data output. That's the reason, which is caused many confusing data, as many responses they choose multiple transportation for multiple choice single answer question. And for transit question, we didn't consider the transferring numbers of the same transportation. That caused us a confusing data of access time and waiting time. A location intersection question has one response field with two parallel street names. Validation questions are very helpful to correct many wrong inputs, and the Google Maps also helped with many transit data that are missing access time and travel time input.
Hello, my name is Rezwana Kubir. Here I will talk about modeling of data, then result analysis and conclusion. This is the data we have used in our model, which you can see the parameters are gender, age, income, origin places, which are home and work, then before pandemic travel frequency, then travel time of car, transit, and other mode, availability of car, transit, and other mode, waiting for transit, cost of car, transit, and other mode, distances, and the rest of the parameters are categorical variable which have been used in our model. This is the model formulation. So multinomial no-dip model has been applied for our data with some assumptions, which are the error components are Gumbel distributed. The error components are identically and independently distributed across alternatives. Error components are identically and independently distributed across observations and individuals. So this is the formula in which I stand for cases, J for categories, and K for independent variables. So for the model development, we have used BioGEM 3.2.6 version. We used that for prediction of multinomial logit. BioGEM is an open source Python package designed for the maximum likelihood estimation of parametric models, especially discrete choice models. The travel time, distance, and travel cost variables are specified as generic in this model, which implies that an increase of 1 unit of travel time, distance, or travel cost has the same impact on modal utility for all three modes. You can see that modes are the three types of modes which have been chosen in our model, which are transit, car, and other mode. In other mode, it includes motorcycle, rental sharing bike, and scooter. And in transit, it includes bus and queue line. And transit mode is considered as the base alternative. So these are the utility functions for car, transit, and other mode. So here you can see the travel time, travel cost, and distances have been included in all of the three alternatives, while all the categorical variables or other socio or economic variables have been included only in car utility for simplicity of the model. Now I will talk about result. So here you can see the result that number of estimated parameters are 12. Sample size 181, which means 181 observations have been included in our final model. And like loghood, so the result shows the final log likelihood value has been improved over initial log likelihood value. The t-test values are not significant at 5% significance level for all parameters except distance. It is intuitive because the model is based on anonymized survey and may not be fully reliable. However, the model is considered as a good fitted model. Likelihood ratio test is found to be 12.09573, which is almost equal to critical chi-square ratio 12.2 at 0.2 significance level for degree of freedom number of 9. Therefore, model is significant at 80% confidence interval. 12 parameters are included at the model, which are alternative specific constants for car, transit, and other mode, travel time, travel cost, distances, which are generic parameters, age 35 or more, during pandemic travel frequency, during pandemic mode change, before pandemic travel frequency, time saving importance, watch, electronic device. Those are kind of categorical variable, and high income, which is socio-economic information. All parameters are included only in car mode alternative, while travel cost, time, and distance are also included for transit and other mode. Transit mode is the best alternative. The negative sign for alternative specific constant for car and other mode indicates that more people are likely to choose train over other mode and car. It may be the reason it can be because the lower cost for transit alternative. The estimated coefficients on the travel time and cost variables are negative, which is expected, implying that the utility of a mode decreases as the mode becomes slower or more expensive. Higher amount of people with age 35 or more are found to choose car. It can be related to people's income and health, meaning with increased age and income, people prefer to choose car compared to transit based on comfortability. People with high income are positively correlated with choosing car. It suggests that people with high income have their own car to do the travel, to make the trip, therefore utility of car gets increased. Estimated coefficients for distance parameter is positive. It means that the utility of a mode increases as distance increases, and it holds true for car, transit, and other. For people with the car mode, time-saving importance parameter was found positive, implying that people who would like to save more time from travel, they prefer to choose car more in a rather than transit and other mode. The coefficients of watch electronic device frequency are negatively associated with car mode, implying that the utility of a car decreases as people prefer to watch electronic device often during traveling. Therefore, people who prefer to watch often, they will select other modes, for example, transit and other mode which are rental sharing bike or scooter rather than car. Before pandemic, frequent traveling from home or work to university has positive coefficients, implying that utility of car mode increases for frequent traveling before pandemic situation. Therefore, people who go frequently to university, they used car more. During pandemic, frequent traveling from home or work to university has negative coefficients. It is intuitive because people with car mode are negatively correlated with the parameter travel university frequently during pandemic because during pandemic less amount of people will go to university, so this result is intuitive. Pandemic change mode parameter is negatively associated with the car mode utility. It means that people who have car, they do not want to change their mode to any other alternative. After running initial models, several parameters have been discarded since those parameters showed insignificant coefficients as well as the sign of the parameters was not shown in a reasonable way. The utility of a mode and the probability that will be chosen, it changes as the coefficient of those parameters of that mode changes. So now it is the aim of this section is to demonstrate marginal elasticity, which is a value of time. We have chosen that value of time can be defined as a traveler willingness to pay for travel time saving. According to the behavioral value theory, value of time is obtained by this formula, which is where value of time equals to C divided by B, where C and B are the coefficients of time and cost respectively for any utility. According to our model, our VUT is found to be 0.595, which means a traveler is willing to pay 0.595 to save 1 minute time, which seems reasonable in our model. So we can conclude that revealed preference survey design instrument is found to be an effective way to get data from university affiliated persons. Though many responses were not complete and survey answers were not reliable, however, survey data has been considered an accepted way to find how travel mode of university affiliated persons are affected before and after COVID pandemic for travel from home or work to university. Multinomial logic model is found to build a model for car, transit, and other mode. 12 parameters are included in the final model with 181 observation, which are travel time, cost, distance, age, travel frequency during and before the pandemic, and then during pandemic changing mode, yes or no, time saving importance, high income or lower income, watch electronic device frequently to estimate the utilities of car transit and other mode. The t-test values were not found significant at 5% significance level for all parameters except distance. Likelihood ratio test is found to be 12, almost equal to the critical chi-square value of 12.2 at 0.2 significance level. The probability of car mode increases with age, distance, income, and time-saving importance perception frequency of travel to university before pandemic. The probability of car mode decreases after pandemic situation, and the probability of transit and other mode decreases with cost and time and increases with distances. Though several parameters were not found to be significant, but however those parameters have been kept to understand the utility change and people's perception about traveling before and after COVID pandemic. So this study revealed that hypothesis in a good way, in a accepted way. So this is my presentation. So these are the references we have used in for our report. So thank you very much for listening.